Question number 71. It says that let Imn is equal to 0 to pi by 2 sin per mx cos per nx dx, where m and n both are greater than or equal to 2 and they are natural numbers obviously, then which of the following is correct? So we have to go for this particular integral, and obviously we all know that we handle it with a plus b minus x property. Why is that so? It is so because sin of pi by 2 minus x कितना होता है? Cos x, और cos of pi by 2 minus x कितना होता है? Sin x. So if I apply a plus b minus x property, so 0 to pi by 2, this will be sin of pi by 2 minus x. So cos power mx sin power nx dx. Imn is clearly is equal to Inm, because first of all, m is the power of sine, n is the power of cos. Here, n is the power of sine now, m is the power of cos now. So, Imn is equal to Inm. So, they are just like brothers. There is no difference if they are interchanged. Okay. So, they are just like twins. There is no difference that if they are, even if they are interchanged. So, according to the options, I can say that I62 is equal to I26, which means that option number 4 satisfies. Okay, very smart question, but we have solved it very, very smartly. Let us move on to question number 72. Question 72 says that when x is lying between 0 to 1, that means x is a fraction. Fractional part x is equal to sin x itself. So this integral is simply 0 to 1 integral sin x dx. Very simple problem. So minus cos x from 0 to 1, that is negative of cos 1 minus cos 0. So cos 0 is 1. That will be equal to 1 minus cos 1. Option number 4 goes correct. Let us move on to 73. Question number 73, based on definite integration, says that let I1 equals greatest integer of sin alpha to greatest integer of minus sin alpha cos pi x by 2 into cos cube pi x dx, and I2 equal to, the limits are same, but in place of cos pi x by 2 there is sin pi x by 2. So students, where alpha belongs to 0 to pi by 2, that means alpha is lying in the first quadrant. If alpha is lying in the first quadrant, 0 to pi by 2, sin alpha lies between 0 to 1, both open. Then greatest integer of sin alpha will be what? Directly equal to 0. Greatest integer of minus sin alpha will be what? Directly equal to minus 1. So by looking at the interval of alpha, we can directly simplify the limits into numerical values. I1 will be equal to integral 0 to minus 1 cos pi x by 2 cos cube pi x dx. I2 will be equal to, again, 0 to minus 1 sin pi x by 2 into cos cube pi x dx. If you will apply a plus b minus x property in I1, you will get I1 equals, x will be replaced by minus 1 minus x. So minus 1 minus x से अगर मैं replace कर देता हूँ, so this term will become minus sin pi x by 2 and this term will become minus cos cube pi x. After applying a plus b minus x property in I1, 0 to minus 1 dx. Clearly, both the negative signs nullify each other. I1 is clearly equal to I2. Option number 4 goes correct. Okay, let us move on to 74. Question number 74, based on area under curve, it says that the area bounded by the curve fx equal to x cube minus 6x square plus 11x minus 6 and the x-axis is. So students, this is a very well-known cubic equation. It has 3 roots, 1, 2 and 3. So let us draw the graph, x-axis and y-axis. One root is 1, another root is 2, then the last root is 3. So f of 0 is negative, the graph will be something like this. There are 3 roots, 1, 2, 3. Okay. So this is the graph of fx. Fx can be written as x minus 1, x minus 2, x minus 3. Obviously we know that this is the required area, this area and the lower area. So this is area is equal to 1 to 2 fx dx plus 2 to 3 minus fx dx, because fx is negative in that interval. So all you have to do is you have to put fx as x minus 1, x minus 2, x minus 3. Make the substitution x minus 2 equals t to simplify your answer very quickly. Okay. So area will be, we'll write the full expression first of all. X minus 1, x minus 2, x minus 3 dx minus 2 to 3 x minus 1, x minus 2, x minus 3 dx. So if you put x minus 2 as t, it will be t minus 1 into t plus 1. The other way around. This will be minus 1 to 0, and this will be minus times 0 to 1 t plus 1 into t minus 1 dt. T cube minus t square minus t integral minus 1 to 0, 0 to 1 again t cube minus t dt. Okay, so this is a relatively very simple integration. Rather than integrating those 4 long terms, the final answer will come out to be 1 by 2, 1 half. Okay, so the final answer goes with option number 3. Okay, let us move on to question number 75 now. Again, based on area under curve, the area bounded by the curve mod y equal to 1 upon 1 plus secant square x in the interval minus pi by 2 to pi by 2 is. Students, pay attention. So secant square x plus 1 is a quantity which is always greater than or equal to 2. 1 upon this is always less than 1 by 2 in the interval minus pi by 2 to pi by 2. Obviously, this quantity is always positive. So let us draw the rough graph of this. From minus pi by 2 to pi by 2, if I draw 1 upon 1 plus secant square x, the value at minus pi by 2 as well as pi by 2 is tending to 0. Something like this. The 0, the maximum value is 1 by 2. And again something like this. This is y equal to 1 upon 1 plus secant square x. If I need mod y, I'll repeat the same graph by taking x-axis as a mirror. So these are the lines pi by 2. The value is tending to 0, okay, at pi by 2. This is minus pi by 2. So obviously the area is very simple now. This is mod y equal to fx. I'll calculate the area. Area will be 2 times integral minus pi by 2 to pi by 2 upper curve. So 1 upon 1 plus secant square x. So put tan x equal to t, adjust the terms, you will get area as, so this integral will be converted to 2 times minus infinity to infinity. Secant square x dx is dt, so multiplying and divide by secant square x, I'll get dt upon secant square x into secant square x plus 1, that is tan square x plus 1 into tan square x plus 2. So t square plus 1 into t square plus 2. This integration can easily be managed by creating a difference of these 2 terms in numerator. So final area will come out to be equal to 2 pi minus root 2 pi, and that is again going with option C. Okay, so answer is option 3. Let us move on to 76.